Hey, this is a support video for students working with the TI84 calculator, specifically for the SAT exam math section 4. For exponential regressions, here's an example that you too can code with your TI84 calculator. The following scatter plot shows the effect of blood alcohol level on relative risk of accident. And for the compared correlation, we have the blood alcohol level along the x-axis and the relative risk of an accident on the y-axis. Now, to make the calculator work a little better, for these 0 to 25 hundredths of a percent, I'm going to enter those in as numbers from 0 to 25. So I'll scale it by 100 on the x-axis. This puts a nicer picture and formula when it's calculated by the TI84. So we're using these 6 data points for our data set. So next we'll take these data points and enter them into the TI84 calculator. Okay, so let's continue now with the TI Smart View CE for the TI84 Plus family of calculators. And what we'll do here is we'll create the graph that I've shown here in this cell. This is a very nice graph because as you can see, the window settings show all the plot points. If you click trace, you can go through this set of plot points. Here are data points that we're about to enter. As well as the graph, if you click down arrow, it should shift to the graph, which you can see is 1.20 is the starting value, and R is also 1.20 to the X. And we can trace along following the best of line exponential fit. All right, so let's go to the data entry here. We're going to hit Stat together, and it should bring up this menu, Edit, Calc, and Test. Choose choice 1, or you can just hit Enter because it's highlighted. You can actually type the number 1, and it will also work. And what we're going to do is we'll enter into the first column those hundredths of a percent for the blood alcohol level. And then in column for list L2, under that heading, we'll enter this set for the relative risk of accident. So I'll give you a moment to enter this data. Please pause the video if you are teaching, and we'll continue after the 6 data points are coded. Right now, you should have all 6 of these data points coded for the calculator. And what we'll do next is we'll go to the window settings. Now, notice that X is spanning between 0 and 25. So I want to make sure that X is between 0 and say 30. And Y is going from 1 to 90. So I want to make sure Y is between like 0 and 100. So based on those ranges, the domain and the range, based on those values, let's go to the window setting. So what I've done is I've set the X values to go from -1 to 30. So I get a nice picture. And it'll scale it with a little tick mark every 1 unit. But maybe I want to change that. I want to change that to scale every 5, right? And then for the y-axis, I'm going from -10 up to 110, but I wanted to place a tick mark every 10 units. So I put 10 in there. That should do it. So when I hit graph, there's a nice picture with, here we'll refresh down here with the window settings down here from -1 to 30 for X for the domain across the window, and with a scale of 5. So each of those lines represents 5 hundredths of a percent. And then for the Y minimum, -10 to 110. So I can really see the origin and I can see the axes on my picture. And again, each of these marks represents 10 units for risk based on the alcohol consumption. All right, great. Make sure that if you do second stat plot, that the plots are on. So again, choosing 1. You can toggle these on or off, the points. And what I'll do is I'll leave it on, but just to show you that I did so, I'll change this to orange, okay, like caution orange for this example. And then when you hit graph, those same boxes will be changed to the orange color, contrasting with the blue line. Well, now that you see that we can plot our data points, we have to create this blue line here, which is a exponential regression. So what we'll do is, again, we'll click Stat, right arrow to a Calculate menu. And here you have different types of regression lines that fit. Now, this data is not linear. If we do graph it linearly, you'll see that the correlation coefficient is quite low. All right, but however, if we do an exponential regression, we have a formula that's a much better fit for this relationship. And again, we'll store it with vars, y bars, the function y1. So now it writes the code y sub 1 for the store location for the stored equation. That'll make the blue line. It's the first on the set of y of 10 equations that you can store. Click on calculate, just hit enter. And it tells us here that y equals a b to the x, as long as the starting value a is about 1.206, and the growth rate is 1.208 to the x. And the correlation coefficient is quite high, as you can see, it's 0.977 with an R being 0.988. So a very good fit for these data points. And what I'll do is I'll go to y equals, and as you can see, the equation has about 12 decimal places. So in the second line in red, I'll round that to 1.206 times 1.208, close parentheses, raised to the x power. All right, so this is the same equation, but if you want to just round it to the nearest thousands, such as this example, you'll see it traces over it, but there will be some variation probably, even with, as you can see here. No, it's pretty good. It's pretty much on top, and you can see as x increases, it will deviate just a little bit from the original blue line. But there you have it. That's your graph of the data points with its best of line exponential fit. You can then go to the table for these values 1, 2, 3, 4, and 5. Skipping by 5, excuse me, to be 5, 10, 15, 20, 25 for these alcohol, the alcohol intake. And you can actually analyze them. So you can enter values like 0, 5, 10, 15, 20, 0.25%, and even go up to 0.5% alcohol, blood alcohol level. 1% would be 100. Or even 1.25% blood alcohol level. So you can see the predicted amount of risk gets quite high. It grows exponentially. So certainly, if you were say a bartender and someone you have an alcohol level test, and you can see that they're even in the 15 to 20 range, or even the 5 or 10 range, you might want to make sure they get a cab or a car service to take them home safely for the night. Anyway, that's one example. And for a best of line fit, again, for a exponential equation fit. Here it was the healthcare of blood alcohol level, if you're drinking drinks that have alcohol, and the risk of harm or accident. All right, thank you for watching my video, and I hope this is useful to you in your preparation for your upcoming SAT exam.